You define an interface using the interface keyword. You implement an interface using the same colon syntax that you use to inherit a class. The main difference between inheriting a class and implementing an interface is that a single class can inherit from only one class, but can implement as many interfaces as it needs to. If the class implements multiple interfaces, use a comma delimited list of interface names after the colon, all of which must follow the base class name, if any. Here's the code for the iCustomer interface in the sample project. It includes the same properties and methods that I used in the regular customer class. But it's important to notice here that there's no implementation code for any of the properties or methods. So you can see all the properties, all the methods. So it almost kind of looks like an abstract class. So what's going on here is that there's enough there to determine whether the properties are read-only, write-only, or read-write, as well as their types, and to know what parameters the methods take and the return types of those methods. Okay, so it's just the declarations of those objects. So I can't include any implementation code within the interface definition. Okay, and I know this is an interface because I use the interface keyword right there. Now, as a convention, the names of the interfaces defined in the .NET Framework all begin with capital I. So that identifies it as an interface. So it makes it really easy to tell what's a class and what's an interface. It's a good programming practice, and one that I highly recommend, that you name your interfaces in the same manner. That helps make your code much clearer, making it easy to see what's going on in your classes. Okay, so I have this definition of an interface, and now I want to implement it. So I'm going to come over here, Solution Explorer, right-click, and add a class. And I'm going to call this Customer I. So just to distinguish it that I'm implementing an interface. Okay, in order to tell the compiler that I want to implement that interface, I just use the same colon notation as deriving from a class and put in the name iCustomer. Okay, so notice immediately get a red squiggly because as soon as I write that code right there, I'm telling the compiler that I'm committed to implementing whatever that iCustomer interface defines. I'm committing to implementing it within this class. But I haven't done that yet, so I can't compile this code. If I hover over it, you can see that I actually have a number of errors. Just like with the abstract class, if I go to the error list, I have a whole bunch of errors because there's a whole bunch of members that I haven't implemented within this class yet. Okay, and so the individual items say customer I does not implement interface member iCustomer.customerID or customer name or city or whatever. I haven't implemented any of those features within the application. Okay, so it looks a lot like the problem when you first say that you're deriving from an abstract class. All right, so this is yet another kind of conceptual similarity between abstract classes and interfaces. Okay, they're quite different things, but there are a lot of similarities. Okay, once again, the good news is that quick actions to the rescue. And what's interesting here is that I have two different options. I can implement the interface, and as you can see, I once again get a preview of what that's going to look like. So it's going to create a public string city, getter, throw a not implemented exception, setter, not implemented exception, and so forth. Okay, and I can scroll down and has all the properties and all the methods, everything that's defined within that interface definition. Okay, but then there's a second option here to implement the interface explicitly. So what this is going to do is that it fully qualifies each member name with the interface name, such as iCustomer.customerName. So it's kind of small on the on the screen here, but that says string iCustomer.city. Whereas just implementing the interface, that first option right there, just said string city. Okay, can scroll down and see all of that it basically includes all the same stuff. The only difference is that I'm explicitly implementing it with the iCustomer keyword. Okay, so part of the advantage of this or reason for it is that it lets you implement 2 or more interfaces that have similarly named members, such as customer name or whatever the property name is. Generally, that isn't an issue. So more often, at least initially, you're probably going to want to select the implement interface. It's a little bit cleaner. Because the other thing about this is that you can't directly call an explicitly implemented interface. So what this requires is that for the get customer info, I have this definition of the member, but then I also have to declare within the class a void get customer info that explicitly calls that method. Okay, so you would need to create public members with the same names that call the implemented members. Okay, so a little bit more work. Generally, you're probably going to want to stick with just implementing the interface. And that's what I'm going to do here. So I'll go ahead and select on that option. And there you can see all of the code that Visual Studio added. Okay, public string city, not implemented exception, so forth for the getter and setter. It is going to do the right thing for whether these are read-write properties defined within the interface. And it has the implementation of the methods as well. Okay, and if I scroll back up here, move off there, I no longer have a red squiggly under iCustomer because I've implemented all of the members that I said I would. Not with real code yet, but the next step is to then flesh those out with actual code. So it's important to understand that a class that implements an interface, which is that right there, saying that it implements the interface, has to implement all of the members of the interface. But you can override and overload interface members the same way you can override and overload base class members. And in that regard, you use an interface in a manner similar to the way that you can use an abstract class. But an important difference between an interface and an abstract class is that a class can implement multiple interfaces, yet it can only derive from a single class. Now you can use interfaces to implement smaller sets of members and to enable classes to implement only the interfaces that they need. So I have another interface here called iCorporateSales. Notice that this is a much smaller interface. In fact, a lot of the interfaces that you'll define and a lot of the interfaces within the .NET framework implement only a single method. In this case, we have a credit limit property, and then we have a change credit limit method and a record orders method. So these are a property and a couple methods that are related to sales to corporate customers. Okay, so presumably I'm going to implement this interface on some sort of a customer, some sort of a corporate customer perhaps, that I want to make sure explicitly implements these features. I'll come over here and open up customer 4, and you can see that here is customer 4 that is implementing both iCustomer, so it has to include all of those properties and methods, as well as iCorporateSales, that interface that I just showed you. And in fact, this shows you how you can implement multiple interfaces. If I was also deriving from a base class, I would include it there. It has to be the first in the list. And then I can list out as many interfaces as I want to implement in this class. And in fact, if I add additional interfaces, I'll immediately get the red squiggly until I provide that implementation. And I can once again hover over it. I get the quick action option to implement the interface, and it'll put in whatever properties and methods are appropriate for implementing that interface. And what's interesting here is that all of the features of the customer, iCustomer, and iCorporate sales interfaces are intermixed in alphabetical order. So if I come down here, postal code, region, change credit limit. Okay, so this is a method. It's in alphabetical order. The properties are separated from the methods, but the corporate iCorporate sales methods are interspersed with the iCustomer methods in alphabetical order. So it inserted them all. So it's kind of weird, but again, you can go through and put them in a different order if you want.